This is Physics 275 Lab. The title of today's lab is Speed of Sound. In addition to this video, there will also be a data sheet online that you can use to complete your lab. These are the materials that we're going to use for our Speed of Sound lab. First, we have a tube with a meter stick inside of it and a microphone that you can move in and out. There's a speaker on this end of the tube. We have some cords for the microphone, cords for connecting the speaker to our frequency generator or our function generator, and then also to our oscilloscope right here. Okay, so we have all of our materials here. As you can see, nothing has been plugged in yet. Actually, also switched the oscilloscope and the function generator because one of the cords went across the screen. So here is our microphone cord. We're going to plug this into our oscilloscope. So now we're getting signal from here. Make sure the microphone is on. I have this jig already made up for the function generator. I'm going to put it underneath our tube and plug it in. And then also attached to this jig is another cord that's going to go to our oscilloscope. So now the oscilloscope knows when the pulse is generated by our function generator, and it also is getting signal from the microphone when the sound is detected. Now that everything has been plugged in, we're going to test to see if we get any signal. I'm going to put the oscilloscope to default setup, and I'm going to turn on my function generator to about 10 hertz. I have it on the sine wave function, and over here are my scale knobs. So I'm just going to increase the scale, make sure I'm getting some signal. As you can see from the oscilloscope, there's definitely some signal. We're definitely not in the right settings right now though. So the first setting that we're going to look at is we're going to go to the trigger menu, and we're going to go to our source, and we want external source. Good. And next we're going to adjust our horizontal scale to 500 microseconds, and actually I was already on it. 500 microseconds. Now our trigger, there's a little marker right here, a flag that shows us where the trigger, the pulse is being generated, at what time it is. We're actually going to move that over to your left, and I'm going to just move it to about right there. Line it up with one of those dotted lines and adjust my trigger levels, make sure that everything's good. Okay, so that's the setup for the electronics. Okay, now for the data acquisition part, I'm going to first show you guys that there is a meter stick in the tube, and then I'm going to do a zoom in on the oscilloscope. Okay, so I'm just going to show you guys real quick. We do have a meter stick inside of our tube, and as I move the microphone, you will be able to see it move up and down the meter stick. Okay, so now we're looking at our oscilloscope screen. We can see that there are grid lines on our screen, and because of our settings, we set one of the horizontal grid lines to 500 microseconds, So the distance from here to here will be equal to 500 microseconds. We're setting our coordinate system 0 at this grid line. And so then from here to here we'll be at 500 microseconds. This will be 1000 microseconds, 1500, 2000, and so on. Now, this is the harder of the two measurement devices to read. So we're going to take advantage of these grid lines. We're going to take values at 250 microseconds, at 500 microseconds, 750 microseconds, 1000 microseconds, and so on in 250 microsecond intervals. So we're going to start off with the point that we want to follow. Some people will follow peaks. I like to follow this little part because the peak can, as I pull it out, the peak kind of changes. It goes down and then another peak rises. Sometimes it changes shape. That time it didn't change shape as much, but this is a better way to take the readings. So I'm going to use this part right here to take all my readings. So for my first reading, I'm just going to place it at 250 microseconds. Now I can go to my meter stick and record the exact amount of distance between the microphone and the speaker. And then I can pull it until it hits the next grid line, so that's 500 microseconds. And I'm still looking at this point right here. I can record my data for the distance, then move it. Now it's about 750 microseconds, again looking at this point. And then you basically will continue this until you run out of meter stick or microphone. Just keep pulling it out and taking data, and you'll see how it just kind of moves along as I pull the microphone out. And then kind of drag it and make those weird noises, but good. Next, you'll find the theoretical speed of sound from a formula that will be in your data sheet. With the value for the theoretical speed of sound, you can now determine the margin of error associated with this experiment.